Okay, so for my first question, we're starting with Chapter 1 in the Student Companion Workbook, and it's going to be Section 1.2. Number 3, describe how DNA bases pair with each other. Notice that the larger purine base always pairs with the smaller pyrimidine base. So purine rings are double rings, and they are adenine and guanine, and pyrimidine rings are single rings, and they are cytosine, uracil, and thymine. To explain DNA, based off of the Watson and Crick arrangement, DNA consists of two strands, and both strands are bonded together based off of their base pairs, specificity based off of their base pairs, and each base pair is bonded by hydrogen bonds. For example, the double helix. The Watson and Crick base pair specificity. If you notice in the pictures, we have hydrogen bonding with adenine and thymine. They are both opposite base pairs, and they bond making two hydrogen bonds. As for guanine and cytosine, they make three hydrogen bonds. Sometimes adenine can also bond with uracil. To reference the answer to this question, you can find it if you read through page 4 through 9. And another similar question that may come on the exam, probably not, but something maybe like define and support Watson and Crick DNA arrangement. How many bonds do each pair make? Okay, so question 2. We're having this one in Chapter 11 in the textbook, Edition 8, and it's number 18. It says, a lost property. Glucose and fructose are reducing sugars. Sucrose, or table sugar, is a disaccharide, consisting of both fructose and glucose. Is sucrose a reducing sugar? Explain. So here, a reducing sugar is basically any sugar that reacts as a reducing agent. It happens because it has a free aldehyde or a ketone end, and it can be oxidized. For example, filling solution. When it reacts with carbohydrates, the color changes from blue to red, identifying that it is a reducing sugar. Now, sucrose is a disaccharide. Glucose and fructose joined together by a glycosidic bond makes sucrose. Glucose and fructose are monosaccharides, so they have free ends. When they do come together and join, their free ends are connected to the acetals. So this bond indicates that they have no free aldehyde or ketone end. So sucrose is not a reducing sugar. And to be able to identify or explain this answer, you can visit page 321 of the Biochemistry book, Edition 8. Now, you may see a question, maybe not, in the exam saying, explain if sucrose, lactose, maltose are reducing sugars. If not, why? It's best to know how to explain the difference between those three and if they are reducing sugars or not. Okay, so for question 3, we have Chapter 18 in the textbook, Edition 8, and we're doing number 13. It says structural considerations. Explain why coenzyme Q is an effective mobile electron carrier in the electron transport chain. So first we have to know that electrons are transferred from NADH to O2. Electron flow is exergonic, and it transports protons across the inner mitochondrial membrane. This happens via the citric acid cycle. And also FADH2 enters the citric acid cycle and is generated by a reductase, a Q reductase. And the electron flow is catalyzed by 4 protein complexes. You can find all of this information from page 529 to 531. So basically, energy is released, the energy is used to make a proton gradient. To answer this question, you have to understand what coenzyme Q is. Coenzyme Q is an electron carrier. It is hydrophobic and it carries electrons from one complex to another. Okay, so it carries electrons from NADH to Q cytochrome C oxidoreductase. It takes electrons from FADH2 to Q cytochrome C oxidoreductase as well. Because of its hydrophobic nature, it diffuses rapidly within the inner mitochondrial membrane using its 5 carbon isoprene units. A popular coenzyme Q would be coenzyme Q10, and you can also find that in the book on page 531. It is best to know what happens when each coenzyme Q is oxidized. Because it has so many oxidation states, it is important to know what happens and how it happens, and the mechanism of each, which you can also find on page 531.